The Perseverance rover is getting ready to explore an entirely new area of Mars, and it's been busy collecting samples in tubes just like this one as we get ready to bring them back to Earth.
Welcome to the Mars Yard, where test rover Optimism has been busy helping the Perseverance team prepare as they enter into a new area on Jezero Crater. Mars sample return principal scientist Minnie Wadwa is here to tell us why that area is so exciting. Welcome, Minnie.
Thanks very much, Marina. And we are really excited about exploring this new region that we're going to be in, because now we're starting to get to the margin of the crater, where from orbit we've actually seen the strongest signal of a mineral called carbonate, which is deposited by liquid water here on Earth. And so that's what we're hoping to discover as part of the Mars Sample Return Program, where we are bringing back samples that Perseverance is currently collecting. We'll bring them back here to Earth. My responsibility is to bring back those samples so that we can answer the highest priority science questions to try to understand how rocky planets form and evolve and form potentially habitable environments.
What type of tests and preparations have been going on for Mars sample return?
Mars Ascent Vehicle is going to be the first time that we launch a rocket off the surface of another planet to bring these samples into Mars orbit. And sample retrieval helicopter that we're testing, based on the Ingenuity helicopter. The sample retrieval lander, of course, is the biggest lander that we're going to land on Mars. And we're testing the footpads of that lander, and that's been really successful as well. So Mars Sample Return over the last few months has been testing all of these different components just so we can be absolutely sure that this is technologically feasible.
Why are you so excited about the potential science that's inside those tubes?
Mars Sample Return has been a science priority for decades. We've explored Mars now a number of different ways, from orbiters, landers, rovers, and we've found that Mars actually, in the ancient past, was very different than what it is today. It was actually a much warmer, possibly much wetter place, and there might have been some ancient microorganisms that inhabited that environment. And so there's so much to learn, so much incredible data that's going to come from studying these samples. And there's going to be so many scientists from across the world that are going to be involved in the analysis of these samples and interpreting the data. The kinds of analyses that we really need to do on the samples to answer the important questions about the planetary scale evolution, about the possibility of ancient life, we actually have to analyze the samples with a precision and with capabilities that really cannot be carried to Mars. We have to bring them back to laboratories here on Earth. I have always dreamed of bringing these samples back and studying them in my own laboratory, and that dream is about to become reality.
To get the latest updates on Mars missions, follow @NASA-JPL and @NASA-Mars on social media, or take a deeper dive on the mission websites at mars.nasa.gov.